Hi students. So in this video we are going to discuss about remainder theorem of a polynomials. So remainder theorem. So what is the remainder theorem? So what is the use of remainder theorem? We are going to discuss in this concept. Let p of x be a polynomial. Let p of x be a polynomial. Let p of x be a polynomial of degree greater than 1. So of degree n greater than or equals to 1, of degree greater than 1, so of degree greater. Let p of x be a polynomial of degree greater than 1 and small a is a real number and small a, and let a be any real number and a be any real number. Let a be any real number if p of x is divided by a linear polynomial x minus a. If p of x is divided by a linear polynomial x minus a, then the remainder is p of a. This is the statement of remainder theorem. What remainder theorem says exactly? Let p of x be a polynomial. If you take any polynomial of degree greater than 1 and a is any real number, these two are conditions. Now coming to, this is the original statement. If p of x is divided by a linear polynomial x minus a, then the remainder is p of a. X minus a, so divide cheste remainder p of a vastundi. So what is the use of this theorem? What is the application of theorem? Without doing actual division, we can find the remainder. Without using actual division, one can find the remainder of a polynomial. So that is only by linear polynomials. That is the limitation of this remainder theorem. Now how to prove this remainder theorem? We have to see the proof. Let p of x is a polynomial. We know that p of x is a polynomial. Let p of x be the dividend and x minus a is divisor. Because we already know, so p of x is divided by x minus a. That means which is divided by x minus a. That is nothing but x minus a is divisor and p of x is a dividend. So let q of x be the quotient. We know that. So according to the division algorithm, if you take any two numbers, so we are getting two more numbers. So two more numbers as quotient and remainder. Then q of x so is quotient and r of x is remainder. R of x is remainder. So if you consider dividend is equals to divisor into quotient plus remainder. So this is called division algorithm. Division algorithm states that dividend is equals to divisor into quotient plus remainder. So whereas dividend is equals to p of x. P of x is equals to divisor is nothing but x minus a into quotient is nothing but u of x plus, so remainder is nothing but r of x. So why I am going to consider all the polynomials in the terms of x. So that's the reason why p of x is equals to x minus a into q of x plus r of x. So now, whereas the condition of the division algorithm, remainder is always less than the divisor. So remainder is always less than the divisor coming from the division algorithm. So whereas a polynomial degree of remainder is always less than at least 1 degree less than the divisor degree. Degree of remainder. That means here the condition you can say. So degree of remainder is always less than degree of divisor. Divisor in the sense here degree of x minus a. Divisor of x minus a. What is degree of x minus a? Already we observe that degree of x minus a is equals to 1. So here degree of r is less than 1. Less than 1 is nothing but what? 0 degree. So therefore degree of r is 0. That means r of x is nothing but r, constant. So there is no x value in the remainder. That's why it is called constant. Therefore P of x is equals to x minus a into Q of x plus r. So Q of x plus r. Now put x is equals to a. X is equals to a. Yeah, because so we have an ability to take any value in the place of variable. Any value in the place of variable. Now I am going to take it as x is equals to a. X is equals to a. So yes, so if you take x is equals to a in the place of x, you can take a. P of a is equals to a minus a into q of a plus r. So P of a is equals to a minus a 0 into q of a plus r. Then P of a is equals to, this is 0 plus r. Then P of a is equals to r. So we proved that remainder is P of a. So that is the statement. P of x is divided by linear polynomial x minus a. Then the remainder is P of a. So we are also divided. So then we get P of a as remainder. P of a as remainder. This is the proof of the remainder theorem. So very important proof of the remainder theorem, and its application is also very important. Now we are going to see one example, actual method, and so this remainder theorem method, how to get the remainder. Now let me check. Suppose divide, find the remainder. Sorry, find the remainder. Find the remainder. Find the remainder when 2x square plus 3x plus 5 is divided by x minus 2, or you can take x minus 1. So simply you can take x minus 1. So this is question. So find the remainder when 2x square plus 3x plus 5 is divided by x minus 1. Here x minus 1 is a linear polynomial and p of x is a polynomial we are going to find. So now actual division method. Actual method and remainder theorem method. So remainder theorem, actual method you can see. So by using actual method you can take, so polynomial 2x square plus 3x plus 5. This is x minus 1. So now we are going to divide with by x minus 1. So what is the division? Here x is the coefficient, here x is the term. So here 2x square is the term. So we need to cancel each and every step. So how to find that? So that means here we need 2x square, but we have only x term. So you have to get 2x square by multiplying x with 2x. So if I take 2x into x becomes 2x square. 2x square. Now remaining term 2x into minus 1 minus 2x. So if you sign changes minus, this is plus. Now these two get cancelled. The remaining 3x plus 2x, this is 5x plus 5. But here we have only x, but we need 5x. So to get 5x, we are going to multiply 5 to this x. That means this is plus 5. So plus 5 into x, this is 5x, plus 5 into minus 1, that is minus 5. So you can take it as a plus, and this is plus. So this is minus and this is plus. Symbols get cancelled, this is answer. The remainder is 10. Because here the variable is linear polynomial, this is 0 polynomial, this is a what 0 polynomial, so degree 0 polynomial, this is constant polynomial whose degree is less than this degree, that's why we stop at this one. This is called remainder. So this is the actual process to find the remainder. But now we are going to see how to find the remainder by the remainder theorem method. Let P of x is equals to 2x square plus 3x plus 5. According to remainder theorem statement, if a linear polynomial x minus 1, so the given polynomial is divided by the linear polynomial x minus a, then remainder is P of a. If P of x is divided by a linear polynomial x minus a, then remainder is P of a. So in the place of a, we get 1. So that's why here g of x is equals to x minus 1. In the place of a, 1 is there. That's why. So remainder is P of 1. So in the place of x, you can take 1. So 1 is nothing but 2 into 1 square plus 3 into 1 plus 5. So 2 into 1 square means 1 plus 3 into 1 3 plus 5. So 2 plus 3 plus 5, this is 10. So actually this is simple method, whereas finding this one. Here also remainder 10, here also remainder 10. Students, you got to understand what is the remainder theorem and what is its application of remainder theorem also. So you can practice many questions like this, and if you have any doubts, please comment on this video. So I will try to rectify all your doubts. Thank you.